everyone. I am Dr. M. Vigneswari, Assistant Professor, PG and Research Department of Physics, the Standard Fairfax Rajaratnam College for Women, Sivagasi. So in this session, I am going to discuss about wind energy. Wind energy is one of the renewable energy that you all know. So renewable energy resources means that is a replenished energy. So solar, wind, geothermal and hydrothermal, all of them is an example for renewable energy resources. Among that, wind energy is the most powerful one because the Tamil Nadu has created the electricity, more electric power from wind energy only. So these are the objectives of this session. So this session I am going to discuss about what is wind energy and how to convert wind energy into electrical energy and what are the advantages and what are the disadvantages of wind energy. Okay, let me start this session. Okay, what is wind energy? Wind energy is a clean, renewable power source that converts the kinetic energy of moving air into electricity. Driven by the sun's uneven heating of the earth, wind is an inexhaustible resource that produces no direct greenhouse gas emissions during generation. So wind energy conversion. How to convert the wind energy into electrical energy? This is a process. So that process is nothing but the harnessing the kinetic energy of the wind and transforming it into usable mechanical or electrical power. There are so many systems like any modern system is known as wind energy conversion system. Primarily use wind turbines to generate electricity for homes, industries and power grids. So there are so many core components of wind energy conversion system. Let me explain one by one. First of all, rotor or blades. So what is rotor? It captures kinetic energy. Most commercial turbines use 3 blades for optimal balance and efficiency. The next component is nozzle. So the nozzle is nothing but the productive agent. So the productive housing at the top of the tower containing the gearbox, generator and the control system. The third one is tower. Tower means it rises to heights where wind is faster and less turbulent. So there are so many control systems are there. The pitch control, yaw drive, anemometer and wind van. Let me explain one by one. So pitch control, first of all, it can adjust the angle of the blades to optimize power capture or protect the turbine in high winds. The second thing is yaw drive. So it rotates the nozzle to ensure the blades always face the wind. The third thing is anemometer and wind vane. Both of them sensor. It can be measure the wind speed and direction. So anemometer can be used to measure the direction, measure the wind speed, and wind vane can be used to measure the direction of wind. How the wind energy is converted into electricity? So there are so many key stages can be followed. The first one is capture. Wind flows over the aerodynamic plates of your turbine, creating lift like on airplane wing that forces the rotor to spin. The second thing is mechanical transfer. Here the spinning rotor play a vital role. The spinning rotor turns a low speed shaft which is connected to a gearbox in most of the system, which increases the rotational speed to thousands of revolutions per minute. Third one is generation. So the high speed rotation spins on electric generator. It can be often known as synchronous generator or induction type generator. So which uses probably magnets and copper coils. What is the purpose of these two means? It can be used to induce on electrical current. The fourth one is conditioning. Because you know that the wind speed fluctuates. So the resulting cause, the electricity has been produced at unstable frequency and voltage. So that we need power converters, which means where the power converters is nothing but inverters and rectifiers. Both of them, it can be used to stabilize the fluctuating current to match the standard required by the power grid. The last one is transmission. So in the transmission process, a transformer plays a vital role. You know that transformer, the step-up transformer and step-down transformer, so many types of transformer will be there. Actually, the transformer steps up the voltage for efficient long distance transmission through the electrical grid. So these are the components and the process has been involved how the wind energy can be converted into electrical energy. So the next one is so many wind energy conversing systems will be there. So what are that? It can be abbreviated as WECS. So WECS is nothing but wind energy conversing system. So it can transform the kinetic energy of wind into electricity using turbines. Probably it can be classified by so many things. The axis of orientation, speed of the wind, and the deployment of location. Based upon this, the WECS can be classified. Okay. So it includes the horizontal axis wind turbines, vertical axis wind turbines, so, and it can be categorized into utility scale, offshore and onshore, or distributed, variable speed, grid connected systems. So it can be offering highest efficiency. So there are so many types of wind turbine systems are there. In this image you can see the horizontal axis wind turbines, which is named as HAWT, the most common modern type, characterized by 2 or 3 blades. It can be rotating on a horizontal shaft, typically operating in a upwind configurations, not in the lower wind. It should be useful for upwind configurations. So the second one is vertical axis wind turbines, which is named as VAWT. So it can be the features a vertical shaft, allowing the generator to be mounted at ground level for easier maintenance. It can be oftenly used in smaller or specialized applications. The third thing is offshore wind system. So it can be installed in bodies of water, in so many water bodies, utilizing stronger and more consistent winds to generate more electricity than onshore counterparts. Next one is the onshore wind system. So turbines located on land, commonly used in wind farms to supply electricity to the utility grid. The next one is nothing but based on the operating principle, the wind energy conversion system can be classified to fixed speed systems, variable slip system, doubly fed induction generator, full converter systems. Let me explain one by one. First of all, fixed speed system. It is named as type 1 system. It can be operated at a constant speed, regardless of wind speed. Whether the wind speed is wind flow is very high or normal or low, that's not a problem. So it can be operated at a constant speed. It can be often using induction generators. The second thing is type 2. So that is variable slip system. It is used as it can be used a variable rotor resistance. So that should allow a limited range of speed variation. The third one is type 3, that is doubly fed induction generator. It allows for a wide range of variable speed, providing high efficiency and reduced stress and lower cost compared to full converters. And last one is type 4, that is full converter systems. It uses a power converter to fully decouple the generator from the grid, allowing full control over speed and power. So these are the types of wind conversion energy system. So the next one is advantages of wind energy. You know that wind energy is a leading source of renewable power due to its minimal environmental impact on long-term economic viability. Once it is installed, it provides a stable and virtually free fuel source that helps stabilize electricity prices. So first we discuss about core advantages that involves the environmental benefits is the first core advantage. Actually, wind turbines produce zero direct carbon dioxide or other greenhouse gas emissions during operation. You know that wind energy is one of the renewable energy source always does not provide any zero carbon emission. So they also consume virtually no water, unlike thermal or nuclear plants. Because thermal or nuclear power plants, they require more amount of water for cooling the system. Here there is no need of water. The second advantage is renewable and inhospitable. Powered by the sun's uneven heating of the atmosphere, wind is the resource that will never run out. The third one is cost effectiveness. Land-based wind is one of the lowest priced energy sources available today. While initial setup costs are significant, ongoing operational and maintenance costs are relatively very low. And the fourth one is economic growth and jobs. The industry supports hundreds of thousands of jobs in manufacturing, installation process and maintenance level. It often revitalizes rural economies through land lease payments to farmers and rangers. The next one is space efficiency. Wind turbines have a small physical footprint, allowing the surrounding land to remain usable for agriculture, grazing or other purposes. The last advantage is energy security. As a domestic resource, wind reduces a nation's reliance on imported fossil fuels and protects the economy from volatile global fuel market stocks. So the next one is the technological and practical benefits. What are the technological and practical benefits of wind energy? Let me explain one by one. First of all, scalability. Systems range from small portable units for individual homes or remote telecommunications to massive offshore farms powering entire cities. So the second thing is off-grid capability. Wind is an excellent for providing electricity to remote or isolated areas where connecting to a central power grid is too expensive. Fast deployment, that is wind farms can often be constructed and commissioned in a matter of months, much faster than traditional large-scale plants. Last one is high efficiency. Modern turbines are highly efficient, with some producing up to 23 times more energy over their lifetime than was required to manufacture and install them. The next one is, these are the advantages, and the next one is disadvantages of wind energy. While wind energy is a leading clean energy source, it represents several logistical, environmental and economic challenges. Let me explain one by one. First one is intermittency and unpredictability. Wind is a variable resource. The turbines only produce electricity when wind flows. This requires expensive backup systems like grid-scale batteries or alternate power plants to ensure a steady power supply. The second one is high upfront cost. Although operational costs are very low, the initial investments for manufacturing, transporting and installing massive turbines is sustainable. The third thing is impact on wildlife. Rotating blades pose a collision risk to birds and bats. Construction can also disturb local habitats and migration patterns. Fourth one is noise and visual pollution. Turbines generate mechanical and aerodynamic noise that can disturb nearby residents. Many people also consider them eyesores that spoil natural landscapes, leading to local opposition. The last one is remote locations and transmission. The windest areas are often far from the cities, which need the more power. Building long distance transmission lines to connect these remote sites to the grid adds significant cost and complexity. There are some other local disturbances are also there because of wind energy is having lot of advantages. It also having lot of disadvantages. The one is a shadow flicker. The rotating blades can create a straw effect when they block the sun, which can be irritating for those living nearby. The second thing is signal interference. Large turbines can occasionally cause electromagnetic interference with radio or TV signals. So third one is recycling challenges. While most parts are recyclable, older turbine blades made up of composite materials which are difficult to process and often end up in landfills. These are the disadvantages. So already I said wind energy is the most powerful energy of renewable energy resources because we all know about wind energy. What is the reason? Why we have to know the wind energy means Tamil Nadu can create electricity from wind power. It can secure the second place. The first place is secured by Gujarat. The second place is Tamil Nadu. So Tamil Nadu currently holds the second highest installed wind energy capacity in India after being surpassed by Gujarat in 2023. Despite this, the state remains a global leader in wind power, the total installed capacity exceeding 11,500 megawatt, a flat of 24 and yearly 2025. So some current capacity and performance, let me explain one by one. The total installed capacity approximately 11,500 megawatt. This is the total installed capacity of wind energy. So the state recently set a new record with wind energy evacuation reaching an all-time high of 123.85 million units in a single day in August 2025. So there are so many contributions. Wind energy contributes approximately 9.91% to 15% of the state's total annual power consumption depending on seasonal factors. So there are so many key sites for that. Muppandal, you already know that Muppandal wind farm in Kanyakumari remains India's largest operational onshore wind farm with a capacity of roughly 1,500 megawatt. There are so many new policies and strategic initiatives has been applied by Tamil Nadu and India. So wind powering policy 2024, it can be introduced to replace older inefficient turbines with the modern high capacity models. The integrated renewable energy policy is named as IREP. It can be announced in 2025-2026 budget to streamline solar and wind hybrid projects and reclaim the top national spot. Offshore potential. Tamil Nadu's coastline has an estimated 35 gigawatt to 68 gigawatt of offshore wind potential. The state is collaborating with the National Institute of Wind Energy and Denmark to develop India's first offshore projects. Storage and hybridization. The government is advancing 1,500 megawatt hour of battery storage and promoting hybrid wind solar plants to manage the intermittent nature of wind power. There are so many challenges are also available. So the first one is the aging infrastructure. Nearly 10,000 turbines are older than 20 years and require urgent repowering to improve the capacity utilization factor. The second thing is grid stability. High wind penetration requires significant upgrades to transmission lines to prevent curtailment during peak seasons. And third thing is policy friction. Some developers have raised concerns regarding the financial viability of the new repowering policy, specifically regarding land requirements and banking provisions. These are the challenges of wind energy. I hope you all well known about wind energy and how the wind energy can be converted into electrical energy and what are the wind power systems. So I hope this video is useful to you. Thank you for giving the opportunity. Thank you so much.